Hey, in this video I'm going to give an introduction to NMR spectroscopy, and then I'll have a series of 4 more videos after this that will go into each part of NMR. So number of signals, splitting and integration, chemical shift, and then a final video where we'll look at a couple of NMRs and try to determine the structure based on the NMR we're given. So I want to start with this introduction with just defining what spectroscopy is. So spectroscopy, right? NMR is just one of a number of types of spectroscopy used in analytical chemistry. So spectroscopy is the study of the interaction between electromagnetic radiation and matter. Now specifically, NMR is an absorption spectroscopy. This means that radiation will pass through the sample and excites the electrons in the sample to a higher energy state. Now, what type of electromagnetic radiation are we talking about? Because depending on what type you use, that determines what area of spectroscopy you're going to be undergoing. So NMR, it's low energy. We're talking about a wavelength around 1 kilometer, and that corresponds to radio waves. So you're using radio waves basically when you use an NMR instrument. And what are you doing with those radio waves? You're getting at the nuclear spin of whatever atom of interest you're looking at in your compound. In general, and what I'm going to be talking about is hydrogen NMR. That's the most common one. A lot of compounds, most compounds, have hydrogen in them. And something that hydrogen has is a non-zero spin number, or nuclear spin. Right? The n here is just corresponding to an integer. Right? This could be 3 halves, 1 half, 5 halves, depending on what the integer n is. So you can use NMR for any atom with either an odd number of protons and even number of neutrons, or vice versa. So hydrogen has 1 proton, no neutrons, so you can use NMR for it. Carbon, right, generally it's carbon-12, which would be 6 protons and 6 neutrons, so that wouldn't work. So if you want to do NMR with carbon, you have to use carbon-13. But carbon-13 is much rarer and not in high abundance, so you usually have to use larger samples, and you have to run the sample for a longer period of time. Now, NMR is great because it allows you to determine the structure of a compound. right? You can get an NMR spectrum and from that determine exactly what compound you have, which is really cool and makes it hugely beneficial, especially in an area like organic chem where you're trying to make specific molecules and you need a way to know if you've made that molecule. Last thing to kind of introduce NMR is when you run a sample of NMR, you generally use CdCl3 as the solvent. Right, the D is deuterium, so that is a hydrogen that has one proton and one neutron, which then is invisible to NMR spectroscopy, meaning it won't be seen. So your solvent isn't going to interfere with the sample that you're trying to get.